Now I'm going to move on to the next topic, which is chain rule for two independent variables. Again, in this context of independent variable, I meant that x depends on two parameters, u and v, and y also depends on two parameters, u and v. So suppose x is equal to g of u comma v, and y is equal to h u comma v. These two functions are differentiable functions of u and v, and z equal to f of xy is a differentiable function of x and y. Then z equal to f of g of uv and h of uv
It's a differentiable function of u and v.
And we have the following formula. That is partial z partial u equal to partial z partial x times partial x partial u plus partial z partial y times partial y partial u. So that's one formula. Now, because the function depends on two parameters, u and v, you have a second formula, that is partial z partial v equal to partial z partial x times partial x partial v plus partial z partial y times partial y partial v. So again, in this case, you have two formulas because you have x depends on two parameters, u, v, and y also depends on two parameters, u and v. All right, so let's talk about notations. So the result of partial z partial u is very similar to the case of chain rule for one independent variable. However, on the right hand side, you can see when you take the derivative of x with respect to u, it's not the regular derivative anymore. It should be partial derivatives because x depends on two variables, u and v, and it is also the same for the case of derivative of y with respect to u because y depends on two parameters, u and v. Therefore, all the notations in the formula should be in terms of partial derivatives. So I hope that makes sense to you. Compare this formula with the one in the last theorem. That is, in the last theorem, you have a chain rule for one parameter, for one independent variable. Here you have a chain rule for two independent variables or two parameters. Therefore, in this case, all the notation has to be partial derivatives. Similar to the case of one variable, I also have a tree diagram here to illustrate the two formulas that we have. So we start out with z equal to f of xy. Z is the function dependent on x and y. And x is the function depends on u and v. And y is also a function depends on u and v. When you want to find the partial derivative of z with respect to u, now you're going to follow this branch. You're going to take partial derivative of z with respect to x and partial derivative of z with respect to y. And then in the branch of u, you do partial x partial u and then partial y partial u. And from here, you're going to get partial z partial x times partial x partial u. Similarly, for this branch, you're going to have partial z partial y multiplied with partial y partial u. And then you combine the answers together to arrive at the formula of partial z partial u equal to partial z partial x times partial x partial u plus partial z partial y times partial y partial u. Now similarly, we're going to do this for the branch of v. So first we're going to take partial derivative of z with respect to x, and then we're going to do partial x partial v. And from here, we're going to get partial z partial x times partial x partial v. And from this branch, you're going to take partial derivative of z with respect to y, and then you do partial y partial v. From here, you're going to obtain partial z partial y times partial y partial v. All right. Now we're going to combine the results together and arrive at the following answer. That is partial z partial v equal to partial z partial x times partial x partial v plus partial z partial y times partial y partial v. So I hope that you see where all of this formula coming from and how to actually derive the formula. Okay, so that is the formula. Now we're going to apply this formula to some examples. So we want to calculate the partial derivative of z with respect to u and partial derivative of z with respect to v. For z is the function of the form 3x squared minus 2xy plus y squared, where x is the function depending on u and v, that is 3u plus 2v, and y is also a function dependent on u and v, that is equal to 4u minus v. So we're going to find partial z, partial u, and that is equal to partial z, partial x, times partial x, partial u, plus partial z, partial y, times partial y, partial u. So here you want to determine all the informations that you need before plugging the results into the formula. So that is, you want to find partial z, partial x, partial u, partial z, partial y, and partial y, partial u. So here's the work. So partial z, partial x. So you want to find the partial derivative of the function with respect to x. So that is 6x minus 2y. So for partial x, partial u, you get 3 only. So this is the partial derivative of x with respect to u. So in this case, v is a constant. Therefore, taking the derivative of 3u give you 3, and taking the derivative of 2v with respect to u give you 0. Now you do partial z, partial y. That is equal to minus 2x plus 2y, and partial y, partial u equal to 4. Now plug in all of this information into the formula. You get partial z, partial u equal to 6x minus 2y times 3 plus negative 2x plus 2y times 4. Now I'm going to simplify the result a little bit to make the result look a little bit nicer. So I'm going to distribute 3 into the parentheses and 4 into the parentheses. So I'm going to get 18x minus 6y minus 8x plus 8y, and this is equal to 10x plus 2y. So for the final answer, I'm going to replace x by 3u plus 2v and y by 4u minus v. I'm going to get 10 times 3u plus 2v plus 2 times 4u minus v. And I'm going to simplify this result, and if we do the calculations correctly, we should get 30au plus 18v. Now I'm going to perform the same calculation for partial z, partial v. So that is, you have partial z, partial v equal to partial z, partial x times partial x, partial v plus partial z, partial y times partial y, partial v. So for partial z, partial x, and partial z, partial y, we already get it from up here. Now we just need to do partial x, partial v, and partial y, partial v. So that is, so partial x, partial v is equal to 2, and partial y, partial v is equal to negative 1. So plug in all the information that you know into the formula, and we get that partial z, partial v equal to 6x minus 2y times 2 plus negative 2x plus 2y times negative 1. And I'm going to simplify this result a little bit, and I get 12x minus 4y plus 2x minus 2y, and I should get this to be 14x minus 6y. And again, at the end of the day, we want everything in terms of u and v. So I'm going to replace x by 3u plus 2v and y by 4u minus v. I get 14 times 3u plus 2v minus 6 times 4u minus v. And if we do the calculations correctly, we should get 18u plus 34v. Now I'm going to perform a same calculations for the next example. In this example, you want to find partial z, partial s. You want to find partial z, partial s, and partial z, partial t of the functions f of xy equal to e to the x times psi of y, for x is the function of s times t squared, and y is the function of s squared times t. So again, I'm going to use the formula partial z, partial s. This is equal to partial z, partial x times partial x, partial s, plus partial z, partial y times partial y, partial s. Here, I want to do partial z, partial x, that is equal to e to the x times psi of y. Partial x, partial s is going to be t squared. Partial z, partial y is equal to e to the x times cosine of y. And partial y, partial s is equal to 2st. Now I'm going to plug all of this information into our formula, and I get partial z partial s is equal to e to the x times psi of y times t squared plus e to the x times cosine of y times 2t. So now I'm going to simplify this result a little bit. That is, I see that e to the x and t is the common factor, so I can pull that out, and I get t times e to the x, and I left with sine of y times t plus 2 times cosine of y. And for the final result, I want to replace x by st squared and y by s squared t. And I get t times e to the st squared times sine of s squared t times t plus 2 times cosine of s squared t. And that's it, and there's nothing we can do here to simplify the result even further. Now I'm gonna continue with the next partial derivative, that is partial z partial t. So this is equal to partial z partial x times partial x partial t plus partial z partial y times partial y partial t. Again, we already see partial z partial x up here. Now we just need to calculate partial x partial t and partial y partial t. So you do partial x partial t, and that is equal to 2st, and partial y partial t is going to be s squared. Then partial z partial t is equal to e to the x times psi of y times 2st plus e to the x times cosine of y times s squared. So in this case, you see that e to the x and s are common factors. So you do e to the x times s, and you're left with 2t times sine of y plus s times cosine of y. And for the final result, I'm going to replace x by st squared and y by s squared t. And I get e to the st squared times s times 2t times sine of s squared t plus s times cosine of s squared t. And that's it for the final result. There's nothing else that we can do here to simplify the functions further. Okay, now I'm going to move on to example 5. So very similar to the last two examples, but in this case, I'm just going to focus on one partial derivative. So I want to find partial derivative of the function with respect to r, given the function is x times y, and x is equal to r times cosine of theta, and y is equal to r times sine of theta. So you have partial f partial r is equal to partial f partial x times partial x partial r plus partial f partial y times partial y partial r. Here you have partial f partial x is equal to y only, partial x partial r. You take the partial derivative of x with respect to r. In this case, theta is a constant. So here you get, this is going to be cosine of theta only. And partial f partial y is equal to x. And partial y partial r is equal to sine of theta. And we're going to plug all of this information into our formula. And we're going to get that partial f partial r is equal to y times cosine of theta plus x times sine of theta. And for the final result, I'm going to replace x by r times cosine of theta and y by r sine of theta. And you get r times sine of theta times cosine of theta plus r times cosine of theta times sine of theta. And if you notice that you have, so these two terms are like terms, so you have 2r sine of theta times cosine of theta. If you want to simplify the result even further, you can rewrite this as r times sine of 2 theta, given that 2 times sine theta cosine of theta equal to sine of 2 theta, which is a double angle formula. So that's it for chain rule of one independent variables and chain rule of two independent variables. Now I'm going to move on to another topic, that is implicit differentiations.